Hypothalamus Artificial Intelligence. Presence. The history of OPTEX, the optimization expert system. From the Simplex method to multi-problem models, OPTEX expertise meets artificial brains, moving toward mathematics-based general artificial intelligence. Imagination is the beginning of creation. You imagine what you desire, you will what you imagine, and at last, you create what you will. The history of OPTEX is strongly linked to the professional and scientific life of its creator, Jesús María Velásquez-Bermúdez, founder and scientific director of HYPOTHALAMUS Ai. The two stories feed off each other, as the scientist provides the knowledge to develop OPTEX, and OPTEX generates an idea's results, sometimes unknown, that impact the scientist's vision. The first part of the presentation is the professional life when OPTEX was not existing. The second, the longest, is the joint life of OPTEX and Jesús. Three companies are linked to this story. PDC Ingeniería, founded in 1978. DecisioWare, created in 1990, formally founded in 1995, and HYPOTHALAMUS Ai, founded in 2021. Making high-complexity large-scale mathematical models without programming. Because, in 1978, at the age of 25, Velásquez-Bermúdez chose independent professional life as his lifestyle, leaving academia in a secondary place. OPTEX is a praxis result, since it ends up being the artificial intelligence used to solve all the real problems found in complex mathematical modeling applied to the real world. In 1970, OPTEX, optimization expert system, began to take shape when Jesús Velásquez-Bermúdez, at the age of 17, began his career as a programmer, selling his services by making computer programs, which extends until today, 2024. In 1973, he developed his first professional optimization model, at Federal, Colombia, which included an elementary matrix generator, for models in the agro-industrial sector, to be solved using IBM MPS. At age 22, he obtained the degree of Industrial Engineer and Industrial Engineering Master of Sciences, in Los Andes University, in Bogotá, Colombia. The teacher who guided him was Professor Hernando Duran Castro. From 1975 to 1982, he works as professor and researcher in Simon Bolivar University. The teacher who guided him was Professor Ignacio Rodríguez Iturbe. At the age of 54, he obtained a PhD in engineering, from the Faculty of Mines of the National University of Colombia, Medellín campus. The teacher who guided him was Professor Ricardo Smith Quintero. The professional life of Velásquez-Bermúdez is divided into four periods. First period from 1975 to 1984, First Golden Age, or Silicon Valley in Caracas. A time of growth in all directions, research and entrepreneurship, supported by the Venezuelan oil bonanza. It ends with the beginning of the Venezuelan economic decline, in which for personal reasons Velásquez-Bermúdez returns to Colombia. This stage generated the foundations of high current knowledge. At the age of 25, in 1978, Velásquez-Bermúdez founded, together with three other partners, Proyectos y Diseños Computarizados Ingeniería, PDC, beginning his career as an investor in the artificial intelligence business. To start operations, PDC invested $400,000 in a ModComp Classic 7870 minicomputer to solve complex math problems. This decision entailed developing knowledge in large-scale optimization theories, mainly Bender's theory, to be able to solve complex problems using less than 1 megabyte of RAM and 10 megabytes of disk. The economic effort made by PDC in the acquisition of the ModComp Classic may be compared to the economic effort that modern high-tech companies have to make to access the state-of-the-art of artificial intelligence for decision-making. The current state involves the integration of edge computing and cloud computing to implement highly complex mathematical models. On a practical level, they are only available on super servers with a large number of CPUs and GPUs. Today, HI has established alliances with technology-producing companies to complement its knowledge with the knowledge of other partners working in specific fields. This enhances HI's technological capacity. The main technological developments of optimization carried out in PDC were: development of a bounded primal dual simplex algorithm, PDC primal dual, with multi-pricing, inverse of the base in the form of product, and handling of the A matrix in compact constraint blocks, using dispersed matrix methodologies. Implementation of the pivot and complement heuristics to solve mixed integer programming, MIP, problems. Implementation of the Bender's partition and decomposition algorithm, using a variation of the PDC primal dual method, to handle Bender's cuts as a dense matrix, and compact matrix generation from relational databases in Fortran. At that time, the PDC primal/dual algorithm could be comparable to today's best algorithms, IBM CLEX, Gurobi and Express. PDC solved multiple real problems in water resources engineering and flow prediction algorithms. The most important was the master plan for hydraulic resources of Zone 1 of Zulia. A mixed integer mathematical program, MIP, had more than 30,000 variables, and was solved using Bender's partition theory and the pivot and complement heuristics in the ModComp Classic computer. PDC generated invaluable insights in solving complex mathematical models with limited computational resources. This knowledge was capitalized years later in OPTEX. Second period from 1984 to 1990. Pseudo-lost steps. During this period, Dr. Velásquez-Bermúdez did not carry out work in operations research. Two facts are noteworthy. During 1984 to 1990, Velásquez-Bermúdez was fortunate to work on the assembly and commissioning of two SCADA, supervisory control and data acquisition, systems. The first was the product terminal, at Ecopetrol in Mansilla, Colombia, and the second at the Siderúrgica del Orinoco, in Venezuela, where he was technical leader of the SCADA for the Slag Transport Railway System, 128 kilometers, which includes a mathematical model to scheduling the trains with steel production operations. These experiences introduced him to the world of applied artificial intelligence, through the expert systems commonly used at that time in SCADA systems. During 1975 he studied a master's degree in economics, in which he did not obtain a degree, pending his thesis. In 1976 he won the Alberto León Betancourt Prize from the Colombian Association of Electronic Calculation and Operations Research, ACIO, for the work Primal Dual Surrogate Algorithm. Developed at the Simon Bolívar University, and whose results are currently used in OPTEX to compact the Bender's cuts, avoiding the explosion of cutting planes in the computational algorithm. Alberto León Betancourt is considered the father of the UR in Colombia. Third period, from 1990 to 2018, swimming against the current. It's easy to brainstorm ideas out of the box, when you're already out of the box. Return to the world of mathematical modeling. A time of developing survival skills in a hostile world for the development of complex mathematical models. This gives rise to DecisioWare, DW, a Colombian company that generates a significant increase in productivity in the art of mathematical modeling. During this time, Jesús Velásquez-Bermúdez dedicated part of his practice to disseminating the benefits that operational research should produce for Colombian society. In 2000 he founded the Colombian Society of Operations Research Socio, which he chaired until 2008. Organizing the following congresses: First, Second and Third Colombian Congress of Operations Research, and 2008 Latin Ibero-American Congress in Operations Research, CLEO. CLEO 2008 is the most attended CLEO in history, with more than 1,000 attendees, approximately 400 Colombians and 600 foreigners. In 2007, in Seattle, DecisioWare was the first LATAM company at an Informs annual meeting. The history of OPTEX. OPTEX, the expert system in optimization, is a sophisticated private tool, created in 1990, which has evolved to become a powerful generative artificial intelligence, based on an algebraic database language that manages two types of components: basic mathematical definitions, and advanced concepts for multi-problem models, which together facilitate the creation of enterprise-wide optimization systems, EWOS, based on artificial hypothalamuses, without carrying out computer programming tasks. OPTEX employs structured mathematical modeling, which makes compatible all mathematical models that are developed using OPTEX. The experience gained during the SCADA projects was fundamental in the creation of OPTEX, as it helped Velásquez-Bermúdez to think about developing a platform based on an expert system, typical of artificial intelligence, and not on a platform based on computer programs. Thinking outside the box. Since its creation, OPTEX has been an expert system, in the sense of artificial intelligence, based on a relational information system that stores the algebraic components of a mathematical multi-problem optimization model. OPTEX conceives a mathematical model as the union of mathematical components harmoniously integrated. OPTEX is developed under the principles of structured mathematical modeling oriented to develop multi-problem mathematical models, which is one of the pillars of enterprise-wide optimization, EWO. Thinking outside the box. Since its creation, OPTEX has been an expert system, in the sense of artificial intelligence, based on a relational information system that stores the algebraic components of a mathematical multi-problem optimization model. OPTEX conceives a mathematical model as the union of mathematical components harmoniously integrated. OPTEX is developed under the principles of structured mathematical modeling oriented to develop multi-problem mathematical models, which is one of the pillars of enterprise-wide optimization, EWO. And isolated from the methodologies used in that world that revolved around fourth-generation algebraic languages, such as GAMS and AMPL, which were, at most, 5 years older than OPTEX. This involved separate paths from the beginning of the journey. The first version of the PCSI had the following characteristics. Financed the development of the first version of OPTEX. The Ng Carlos Ibanez programmed the first version of the OPTEX user interface. The PCSI was a multi-problem model that integrated the expansion of the system with month-to-month operation. Multi-level benders was used to break down the problem and speed up its solution. Plex was used as a solver, connected to the generic algorithm of multi-level benders. OPTEX generated program C to solve the problem, and PCSI was solved in a compact personal computer, with 16 megabytes RAM. Until 2015, this system was the central axis of Bavaria's planning system, the largest beer company in Colombia. This year AB InBev bought Bavaria Sabmiller. Initially designed to solve complex mathematical problems using limited computational resources, OPTEX now supports large-scale optimization in any industry. OPTEX's architecture enables autonomous, real-time distributed optimization. This makes OPTEX capable of handling highly complex multi-problem models, by distributing the computation across various platforms using advanced optimization algorithms. OPTEX is based on a computer program developed in Visual Objects, and an expert optimization system that stores all the mathematical models developed, since 1990. This makes it easier to keep the OPTEX models technologically up to date. OPTEX is the central support for HI to be a competitive, a world-class company, in highly complex mathematical modeling and decision-making artificial intelligence. The expert system stores all the components of the mathematical model, managing two types of components, or objects. Basic mathematical definitions, elements that exist autonomously, regardless of belonging to a mathematical model. Making a simile with the molecular structure, the equations correspond to the molecules, which integrate atomic elements, such as indexes, sets, parameters and variables. Problems and models integrate all mathematical molecules, the constraints. Advanced concepts allow complex multi-problem models required by EWOS. The definitions used in OPTEX are: problems, set of equations that make up a specific model. Models, set of problems that represent a specific system. Enterprise-wide optimization system, EWOS, set of models that a company requires to enterprise optimization. Multi-problem methodologies, large-scale optimization methodologies. Artificial hypothalamus, it is the evolution of DSS under Industry 4.0, it is conceptualized as a set of models, which exchange information autonomously, working online, using distributed optimization. OPTEX generate the algorithm of the artificial hypothalamus. This is the current state of OPTEX. Making complex models as a Lego game. The expert optimization system is supported by the artificial hippocampus, which stores structures and processes for scientific decision-making that must be permanently consulted. It stores, like in humans, the experience and the knowledge acquired over time. In the case of model formulation, a modeler should not repeat work every time he modifies a model. The joining, or splitting, of the models is done by keeping the records in tables. That is, in practice, formulating a problem is selecting, by clicking, the equations that compose it, in the same way models are formulated, as if they were a Lego model, which are formed by a set of equations, the Lego pieces. After OPTEX first deployment, the expert system was extended to store the history of all executions of a model, so that this information is used to perform hot starts of the models, accelerating the solution time. Initially, the OPTEX user interface was a data window to capture the contents of tables. The screenshot presents the master table of indexes, and all the tables with relationships with other entities, like variables, constraints, parameters, aliases, problems, data tables, and fields in the data tables. This vision implies thinking outside the box, since the relationships between mathematical elements are not investigated in the computer programs, but they are visualized in a holistic way through the exploration of a database. This input-output interface is generated online by OPTEX, which means that there is not a program associated with the windows, menu, shell and data, and their connectivity. OPTEX, as an artificial intelligence, interprets what is stored in databases, and generates a hologram adjusted to the application. As an output interface, it is still valid, due to the organization and ease of handling of any SQL database. Today the data is captured directly from MS Word, and soon it will be from ChatGPT, or a similar artificial intelligence platform. From its creation, OPTEX conceptualization makes the formulation of mathematical models independent of their implementation, using a specific optimization technology. Then, fulfilling the functions of a generative artificial intelligence, OPTEX generates artificial hypothalamuses on many technology platforms, such as IMPL, IBM Alog, GAMS, AMPL, Mosel, AIMS, C and Python. It also connects with the most advanced optimization algorithms, such as Gurobi, Plex and Express. The models implemented in OPTEX can use multiple technologies, due to the clear division between mathematical model and optimization technology. For 35 years, OPTEX has been a new vision of mathematical programming. This is a totally different vision from conventional mathematical modeling, based on programs and programmers. In addition, the mathematical modeler does not need to know programming languages. Since generative artificial intelligence takes care of the problem of generating algorithms online, without errors. Since 1978, Velásquez-Bermúdez has been a scholar of large-scale optimization methodologies, with two goals: efficiently manage the memory of low-capacity computers, and accelerate problem solution. Initially, the research effort at Benders was aimed at solving big problems in computers with a single CPU and low memory. Thus, from the first version of OPTEX, used in the PCSI project, a version of multi-level Benders partition was used. Subsequently, the research has focused on the development, and incorporation into OPTEX, of parallel optimization algorithms, standard Benders decomposition, multi-level Benders partition, MBP, generalized stochastic dual dynamic programming, GSDDP, multi-Benders decomposition, MBD, and sliding optimization. The current state involves the integration of edge computing and cloud computing to implement highly complex mathematical models, this due to the growth of the power of the mini CPUs and GPUs. By atomizing a system, it is possible to solve the problems in different types of computers. This gives rise to real-time autonomous distributed optimization. OPTEX is ready for this challenge. OPTEX generates RTF documents, visible and editable with text editor programs like MS Word. The RTF contains all the mathematical formulation and the IDAS data model, including the link between the fields of each table with the sets and the parameters that are read as input data. Thus, OPTEX guarantees proper documentation of the implemented models. OPTEX, Visualization. OPTEX reports the primal variables, and the dual variables, in relational tables, and in dynamic tables. From 2005, for applications with specialized users, OPTEX can perform input-output using user-oriented applications, such as GIS systems, for regional planning models. HYPOTHALAMUS is currently working on the connectivity with applications that handle digital twins. OPTEX includes multi-problem parallel model processing capabilities. Its success is demonstrated through numerous significant optimization models, much more than 100, that were born in supply chain optimization. In 2009, Ecopetrol contracted DW to develop a comprehensive supply chain model for its industrial operations in Colombia that included exploration and production, crude oil transportation, refining, biorefining, and transportation of refined products. DW used the OPTEX capabilities to develop multi-problem models, and developed for Ecopetrol the following mathematical problems: oil production, crude oil transportation, crude oil and biomass refining, transportation of refined products, and an integrated model with all previous models. These models can be used independently or integrated into any combination that is consistent. DW designed a system to be run manually. Today the same models can be used under the concepts of an artificial hypothalamus. The current artificial brain of the electricity sector, high power, which has been in development since 1995. The table presents 40 outstanding projects carried out with OPTEX. Information on these and other models is available upon request. HYPOTHALAMUS experience for the following industrial sectors is presented. It is presented in operations research projects, the vast majority carried out with OPTEX, which do not include those carried out before 1990. As part of this process should be highlighted: development of knowledge in the subject of modeling and problem solving using parallel mathematics. Research and implement new large-scale methodologies, algorithms, to support OPTEX in solving large-scale problems. Develop multiple decision support systems, multi-models, for the industrial sector. Based on OPTEX, the artificial brain has been created, to implement enterprise-wide optimization systems. In 1998, Jesús Velásquez-Bermúdez and Germán Nieto Paniagua, an engineer at DW, were awarded by the Colombian Association of Engineers, ASEM, with the Colombian Engineering Award, for the work. SHTG, Integrated Dispatch of Hydrothermal and Gas Systems. The SHTG was developed using OPTEX. In 2006, Velásquez-Bermúdez was awarded with Lógica GS1 Award for Excellence in Innovation in Logistics, and Acalog Award for Research in Logistics. Fourth period from 2017 to the present, creating the Emperor's new artificial mind. Towards a mathematics-based general artificial intelligence. In 2017, Velásquez-Bermúdez began to mathematically explain all the concepts empirically implemented in OPTEX, to establish a mathematical theory that supports the creation of artificial brains, and thus integrate OPTEX with the concepts of artificial intelligence based on neuroscience. This is necessary to insert it into the expansive wave of AI. This process is consolidated with the creation of HYPOTHALAMUS in 2021, at the age of 68, which is a spin-off company that capitalizes on all the knowledge produced at DW, and whose business mission is the development of multi-brain artificial brains. HYPOTHALAMUS core support remains OPTEX. An artificial brain is composed of artificial hypothalamus that is conceptualized as a set of mathematical models, that exchange autonomous information between them, working online, using distributed optimization. OPTEX generates the artificial hypothalamus algorithm. Artificial hippocampus, which stores structures and processes for scientific decision-making, as in humans, store the experience and the knowledge acquired over time. In the case of model formulation, a modeler should not repeat the work every time he modifies a base model, as this process uses the mathematical model shop. After its first deployment, the expert system stores the history of all executions of a model, so that this information is used to perform hot starts, accelerating the time to solution. Artificial cerebral cortex, which represents the connectivity map of all neurons in an artificial brain. Specific tools developed in the last 4 years. Mathematical artificial neurons, superneurons, and mathematical artificial neuron networks. A universal language for mathematical communications between swarms of robots. Large-scale super-algorithms geared towards artificial brain looking at the neuroscience principles. Technological development activities and execution. Algorithms learning, 29:30. Neural networks applied to hot start using an OPTEX artificial hippocampus. Building artificial brains. The artificial brains have been designed, following the conceptual results presented in reports conducted by neuroscience experts. In the process, the similarity between a human brain and an artificial brain for an organization has been discovered in every aspect. If you look at the problem of building a brain, the first big problem to face is the architecture of the cortex, hundreds of millions of connections of human neurons. In the artificial cortex, there will be hundreds of millions of connections of mathematical superneurons, in which each neuron must be built according to the type of function it must fulfill. The work to be done is monumental, and it is utopian to think that a superior being, when building a human brain, would do it manually. The first thing he should have developed is the algorithm that produces human beings automatically. In the same way, you can't aspire to build an artificial brain if you don't have the artificial intelligence that produces artificial brains. Velásquez, in 2021, published on SSRN, the paper Artificial Hypothalamus, Artificial Intelligence and Mathematical Programming Integration, in which the foundations of artificial brains, and more specifically of the hypothalamus, are laid. The article, and others later, carefully studies the relationships between the structures of the neocortex, with those formed when a mathematical problem is atomized, to use large-scale optimization methodologies, oriented to the partitioning and decomposition of systems, and they define the artificial brain in semi-detail. This is a disruptive vision of artificial intelligence, considering the power of computers, the evolution of mathematics, and the Internet of Things. This conference explains in a summarized way this evolution, based on the current state of AI. A complementary document is Artificial Brains, Augmented Artificial Intelligence, Artificial Neocortex plus Artificial Hypothalamus plus Artificial Hippocampus. In 2022, to handle the concept of mathematical intelligence, Ai developed the concepts of mathematical artificial neural nets, MANN, which complement the concepts of artificial neural networks, ANN. Starting from the perceptron, the first artificial neuron created, the knowledge of neuronal modeling has evolved, currently having multiple types of artificial neural nets. This new type of neuron will be called mathematical artificial neuron. Its name was derived from the fact that the neuron is built, based on mathematical models that represent a system, and that it contains logical or intuitive elements. The mathematical artificial neuron is a mathematical model, presumably of optimization, which results from the partitioning and decomposition of a monolithic problem into an atomized model, following the mathematical laws of large-scale mathematical modeling. The communication protocol between the two neurons is defined by mathematical laws developed to solve atomized problems. The modeler can choose the protocol, but not the communication process, which for optimization is based on the scientific laws of duality theory, and for equilibrium problems in mathematical programming with equilibrium constraints, PEC. A mathematical neuron represents a robot, which can communicate with another robot, autonomously, since it knows the mathematical rules that it must respect. This is what happens in the human brain, where autonomic systems communicate with each other to make decisions. The mathematical artificial neuron is the technological evolution from the biological neuron, typical of mental intelligence, to the neurons necessary to represent mathematical intelligence, which until now are not produced by the human being. Like all mathematics, theory is cadent, and for those of us who already work in high-complexity mathematical modeling, it is the logical step we must take. It's just widening the look, and thinking a little outside the box. The mathematical artificial neuron is a mathematical superstructure, representing a complete system. A mathematical artificial neuron network can be a neuron of a larger mathematical artificial neuron network. This law of transitivity is typical of large-scale modeling. This process can be repeated until the smallest mathematical artificial neurons, the atoms of the system, are obtained. A large-scale system can be represented by a mathematical artificial neuron, and covers multiple subsystems, where each of them can be represented by a mathematical artificial neuron. Using large-scale methodologies, the mathematical artificial neuron can be divided into two, or more, mathematical artificial neurons, forming a mathematical network of artificial neurons. This process can be repeated until the smallest mathematical artificial neurons, the atoms of the system, are obtained. When the atomization of the system is pushed to the limit, the atom of the system will be the operation of the system over a period of the planning horizon, under a specific random scenario. If large-scale multi-level optimization methodologies, based partitioning and decomposition of systems, are applied to get the smallest atom of a dynamic stochastic, the number of algorithms they generate could become countless. If parallel processing technologies, such as microservices, are used, the solution of a mathematical problem would be carried out by a swarm of algorithms that work autonomously and permanently to achieve the goal proposed by the decision maker. This algorithm swarm approach is currently used in artificial intelligence to manage swarms of robot, but the rules that robots follow are simple, logical and intuitive, and have no solid mathematical basis. An artificial brain can be visualized as a swarm of algorithms, cognitive robots, which have a communication structure based on a multi-level sparse matrix, and whose communication protocol is governed by mathematical laws aimed at obtaining team results. HYPOTHALAMUS works on the following research and development plus innovation projects. Neural nets applied to warm start using large OPTEX artificial hippocampus. OPTEX GPT and artificial intelligence front-end for OPTEX. OPTEX and digital twins. A universal language for mathematical robot communications. Optimization mathematical problems running in GPUs and quantum computers. The data source for building a model can be the description of the real model, and/or the algebraic formulation, and/or pre-existing models in the OPTEX database. The most advanced project is OPTEX GPT, aimed at updating OPTEX user interfaces, in accordance with GPT technologies, current in artificial intelligence. There will be at least two versions, the first oriented to the modeler, who could become an executive who understands the decision-making problem, in which another of the functions of OPTEX GPT will be aimed at supporting users in specific applications, to accompany them in the process of elaboration, or selection, of mathematical models, the loading of industrial databases, and the interpretation of the results. The main product is the management of IDIS, Industrial Data Information System. This work will be advised by OPTEX GPT, based on the data model of the IDIS database. This includes the verification of the validity of the database, considering the metadata of each of the fields of the tables. To date, OPTEX has completed 35 years of continuous growth and upgrading. Proof of this is the current RAN+I plan that HYPOTHALAMUS is developing to incorporate the latest achievements of AI, such as ChatGPT, to facilitate the dissemination of mathematical modeling in Industry 4.0. In 2024, HYPOTHALAMUS was awarded by the Industrial Engineering and Operation Management Society, EOM, for his research work on artificial intelligence applications in businesses, industries and services. HYPOTHALAMUS won the Industrial Engineering and Operations Management Society, Artificial Intelligence Award. By the work, Decision-Making Artificial Intelligence, the New Artificial Intelligence. The award was presented to the founder and chief scientific officer of HYPOTHALAMUS Ai, engineer Jesús Velásquez-Bermúdez. The new way of mathematics is directly related to the parallel thinking, and today it can be said that like paper-based math, sequential mathematics for single-processor computers, will be in the short term a dead language. As in the human brain, in the future only parallel mathematical thinking will be practical. The new analytics is autonomous, parallel, and distributed. Thank you very much for your attention.